Welcome back. In today's lesson, we're going to be looking at 3 more exponent laws to add on to the 2 laws we already know. There's a reason why we grouped these 3 laws together, because in some ways they're really only one law with a combination of something called, that we learned before, the distributive property. So here is a little exploratory that I'm going to start off with you guys here. If you were doing this in class, you'd be doing this in partners to try and figure it out. But I'm going to do this here just by myself. So I have 2 exponent 4, all in brackets to the exponent of 3. So what does this mean is, we have 2 to the power of 4 multiplied by itself 3 times. That's what this 3 here represents, the 2 to the power of 4 multiplied together 3 times. Now each of these 2's is to the power of 4. So if I look at this, this means 2 multiplied together 4 times. So that right there is this section here. Okay? Now, I look at this here. This 2 to the power of 4 is this section of 2's multiplied together 4 times. And then I have one more here that I'm not going to highlight. I'm just going to underline. 2 to the power of 4 is 2 multiplied together 4 times. So if I look at this to the power of 3 represented everything in the brackets to be multiplied by itself 3 times, right? 1, 2, 3. This exponent 4 meant everything in here, that 2, to be multiplied by itself 4 times. So altogether, we're saying we have 3 groups of 4 2's. Hey, as soon as I say groups of something, what's that meaning? That means multiplication. So I have 3 groups of 4 2's. So 3 groups of 4 is 3 times 4, which gives me 12. So this is 2 to the power of 12. Let's take a look at my next one here. We're saying 3 squared to exponent 4. Okay? So 3 squared all to the exponent of 4. Or 3 squared to the power of 4. Well, let's see what that looks like. So pretty much here, what we're saying is we have 3 squared 4 times, right? So we have 3 squared multiplied by 3 squared multiplied by 3 squared multiplied by 3 squared. We have to repeat this one, multiplied by itself, everything in there 4 times. Now every one of these here have 3 squared, 3 multiplied by 3. So that's going to be 3 multiplied by 3 multiplied by 3. So this one here is done because that's these 2, multiplied by 3. That one's done because that's these 2, multiplied by 3. Oops. And there, so there's another 2. Then we have to go 2 more, multiplied by 3, multiplied by 3. So altogether I have 1, 2, 3, 4, 5, 6, 7, 8 3's multiplied together. So that's the same thing as 3 to the power of 8. Well, let's think about that. We have 4 groups of 3 squared. So that's 4 groups of 2 3's. So 4 groups of 2 is 8. So that's 4 times 2. Now let's take a look at one negative here, then I'm going to go on. So this one here says we have 2 groups of negative 4 to the power of 3. Okay? Well, I look at that. Now, this here we have 3 negative 4's. And here we have another 3 negative 4's. Well, once again, we had 2 groups of, here's one group, 2 groups of 3 negative 4's. So we had one here, and we had one there. So 2 groups of 3 negative 4's all being multiplied together will give me negative 4, because both the negative and the 4 is to the power of 6. We have 6 of them now being multiplied together. Okay? So we're going to figure out what that rule is here soon. Now let's take a look at my next question. Okay. So for the next one here, I'm going to look at this here. So here I have 3 to the power, or let's get this a little bit clearer. There we go. So here I have 3, all this, 2 times 5 to the power of 3. Okay? So everything in here must be multiplied by itself 3 times. So we have 1 group, 2 groups, 3 groups of that. So it's 3 of these multiplied together. Now if we remember, when we multiply, the order of multiplication doesn't matter. 2 times 3 is the same as 3 times 2. 2 times 3 times 4 is the same as 3 times 4 times 2. Okay? The order doesn't matter. So I'm just going to organize all my multiplication. So it's all of my 2's together and all of my 5's together, like I did here. So we have 2 times 2 times 2 times 5 times 5 times 5. So this is saying we want 3 2's to be multiplied together and 3 5's to be multiplied together. So it's 2 to the power of 3 and 5 to the power of 3 for an answer. Let's take a look at this next one here. We have 3 times 4 squared. So that's 3 times 4 multiplied by 3 times 4. Now if I rearrange this, how many 3's do I have? 1, 2. Okay? Then I have 2 4's. So altogether here, I'm going to get 3 squared multiplied by 4 squared. And that's it. Once again, all I looked at this here was all of this must be squared. So all of this must be multiplied by itself. So I looked at it, here's 1 multiplied by itself, which is that. And if we did brackets first, that's 3 times 4 is 12. Well, 12 times 12. So 144, and we break it down into its primes, we'll end up getting the same answer. So from these ideas here, we can make a rule. So here's my first rule. My first rule is called power of a product. So when we apply another exponent to a power, we multiply the exponents to simplify. So what does that mean? This means right here, if I have a base x to the power of m, and all of this to the power of n, that means it's equal to x to the m times n. So let's look at my first one here. We already did an exploratory with one similar to this. So basically what that means here is we have 3 squared times 4. We only multiply the exponents together. And that's going to end up giving me 3 to the power of 8. Let's look at this next one here, b. I have 10 cubed squared. Well, we have a power to another power. So that means we must multiply these. Because that's like saying we have 3 10s, or we have 2 groups of 3 10s. Groups of 3. As soon as we say groups of 3, that's multiplication. So it's 10 to the 3 times 2, which is 10 to the power of 6 as my answer. Okay? So, let's take a look at my last one here. For this one, we have 3 groups of 7 squared. Now if I look at this, this 2 only refers to the 7. This 3 refers to both the 7 and the negative. So this one here is a little bit trickier. Okay? So if I was to do this, this is the same thing as negative 7 times 7 is inside, right? That's negative 7 squared. And we want to multiply that by negative 7 multiplied by 7. Multiplied by negative 7 multiplied by 7. Because the squared, only the 7 is being squared, not the negative. Because in order for the negative to be squared, I would have had to put brackets around the negative and the 7. So if I look at this here now, this is the same thing as negative 7, because we have 3 negatives, 1, 2, 3, so that's going to leave it negative. Negative 7, and then we have 3 positives to the power of 6 is my answer. So we still did 2 times 3 there, but we had to know overall it's negative. And we do not put the brackets around this here. We do not put those. We are just going to leave that negative 7 outside of the brackets. So now, let's look at my second law. So my second law is the power of a product law. What this states is, when we have multiple items in brackets, with an exponent applied to it, we multiply the base of the exponent by the new exponent. Okay? So we multiply each base's exponent by the new exponent. Okay? A little grammatical error there. So right here, this means if we look at this, anything to the power of 1 is just that number. So if there's no powers there, we know it's to the power of 1. So this is kind of like using something that we've learned before called the distributive property. Okay, so this here is essentially the distributive property. Because if we learned before, what are we doing here? We have one base multiplied by the other base. If we're multiplying two numbers together with powers, we add the powers. But we can only do that if my bases are equal. Here we have an x and here we have a y. They're not equal, so we cannot add these powers. So if we looked way back in the day, and we did, when we first learned distributive property, we might have a plus 2 all multiplied by 4, right? So when I did that, I had to multiply this into the a, and then I had to multiply the 4 into the 2. So I got this is equal to 4a plus 2. Now if you remember this here, this is like saying 1 plus 1. But we cannot add these because there's different bases. Just like the a and the 2 we cannot add because one is a variable and the other one's a constant, so we can't add those. So same thing here, we can't add these ones because there's different bases. So we have to use the distributive property to multiply this m into both. So here's my first example to show you what I mean. 2 is the same thing as 2 to the power of 1. 3 is the same thing as 3 to the power of 1. Now we cannot add these ones together because I look at these here, 2 times 3, they're different bases. So this 4 must go to both of these. So that's going to end up getting me 2 to the power of 4 multiplied by 3 to the power of 4. Okay? Let's look at the next one here. I have 3 and I have an x. So 3 times x. Both of these are actually to the power of 1. We just don't write that 1. Now we want to multiply this 2 into both of these. So I'm going to get 3 squared then multiplied by x squared. Or we could end up saying 9x squared for my answer. Let's look at my last one here. We have 4 squared and x cubed. Well, we cannot add these exponents together because we have different bases. So we can't simplify what's in the brackets. So now we must use our distributive property and multiply this 4 into both exponents. So I'm going to end up getting 4 to the power of 8 multiplied by x to the power of 12 as an answer. Okay? All right. So now let's go on to our last law. Our last law is the power of a quotient. So much like the power of a product law, except we apply the exponent to all values in a division problem. So it's the exact same as the power of product, except now we have division. And we learned before, if we remember, if I said x divided by y, if I was looking at that, isn't that the same thing as saying x times 1 over y? Because when we said leavey, samey, changey, wangey, uppy, downy, that's the same thing. So really, multiplication and division are somewhat the same thing. Okay? So we want to apply this to both of these. This m must be multiplied in, once again, to both. That's the distributive property. Or we could write this out like this. X divided by y to the power of m is equal to x to the m divided by y to the m. So let's look at some examples. Here's my first one. We have 5 divided by 6. Well, I look at these are both to the power of 1. I can't simplify these powers and subtract them because my bases are the same. Or, sorry, because my bases are different. So what I must do is use my distributive property. Put this into both of those. So I'm going to end up getting 5 to the power of 3 divided by 6 to the power of 3, or I could write it as 5 to the power of 3 over 6 to the power of 3. Okay? Oh, there we go. Let's take a look at my next one here. Once again, my bases are different. Okay? So if we look at these exponents, we cannot simplify these exponents. And if we divide these, we're going to get a fraction. So let's look at what's happening here. We have to put this 3 into both. So multiply by both. So I'm going to get 78 to the power of 3 divided by 13 to the power of 3. That's the same thing as saying 78 to the power of 3, like this, divided by 13 to the power of 3. So either of these answers would work. Now here's my next one, a little bit trickier. We have a squared divided by b to the power of 4. Once again, different bases, so I can't use my division law and just subtract my exponents because we have different bases. So I must multiply this and use distributive property, multiply this 3 into both. So I'm going to end up getting a to the power of 6, 2 times 3, divided by b to the power of 3 times 4 is 12. Or a to the power of 6 divided by b to the power of 12. And that's it. And we cannot subtract these because they are different bases. All right, now let's look at some challenging ones here. So this first one, well, I could do this two ways. I could do everything in the brackets first. If I look at this, I have the exact same bases, don't I? If I have the exact same bases, I'm going to follow BEDMAS. So 3 squared and 3 cubed, we get to add those. So that's going to be 3 squared plus 3, all to the power of 4. That's the same thing as 3 to the power of 5, all to the power of 4, which is going to give me 3 to the power of 20. Now, I could try and punch this into a calculator, but that's going to take forever. And, well, not forever. Your calculator might even say an error, because that's 3 times 3 times 3 20 times. It's going to be a huge number. Okay, so we're just going to leave it like that. Now, even if we did it the other way, 4 times 2 is 8, and then 4 times 3 is 12, and then I add these, 8 plus 12 is 20. So I could have done this both ways and still have achieved the same answer. Let's take a look at my next one. Okay, so let's follow BEDMAS again. Brackets, okay, there we go. We can't simplify that anymore. Well, now we go exponents. So a power to a power, we have to multiply those together. So that's going to give me 5 to the power of 2 times 3, and that's going to be divided by 5 to the power of 4. So that's the same thing as 5 to the power of 6 divided by 5 to the power of 4. Now, what we want to do here is we have division, so we're going to subtract. So that's 5 to the power of 6 minus 4 is equal to 5 to the power of 2. And there is my answer. Now, let's look at my next one and my very last one. Okay, so we must do everything in this big bracket first. So I look at this, I have a power to a power and a power to a power. Multiplication comes first. So I have 2 to the power of 3 to the power of 4. That means we have 4 groups of 2 to the power of 3. So I have 4 groups of 3 2s. 4 groups of 3 2s, that's 2 to the power of 12. 3 times 4 is 12. Now I'm going to multiply that by, here I'm saying I have 5 groups of 2 groups of 2. So 5 groups of 2 2s. That's going to be 2 to the power of 10. Okay? And we're going to divide this by, well, what's anything to the power of 0? It doesn't even matter what anything is in here. That's just going to be 2 to the power of 0, which is 1. Anything to the power of 0 is 1. Okay? 3 times 0 is 0, so it's 1. And then anything to the power of 0 is 1. Okay, so now we have multiplication here. So that means we must add these. So it's going to be 2 to the 12 plus 10 divided by, well, 1. I don't even have to put divided by 1, do I? So this is going to give me 2 to the 22 as an answer.